Okay, folks, now in all drugs that we'll talk about in this class, we have these chemicals made up of many atoms bonded to each other. And so as chemists, we kind of represent these bonds and these atoms by drawing structures. Now there are more complicated structures, and that's what we're going to start with now, because it shows you pretty explicitly how all the atoms are bonded to one another. Let's start with the common drug, ethanol. So ethanol has two carbon atoms bound to each other. The first carbon atom is bound to 3 hydrogens. The second carbon atom is bound to 2 hydrogens. And then finally, off of that carbon atom is 1 oxygen, and off of that oxygen is 1 hydrogen. So this structure shows you how all of the various atoms are bonded to each other in ethanol or drinking alcohol. And you can see that, for example, this carbon is sharing electrons to 1, 2, 3 hydrogens and 1 carbon. But this can be a lot to look at for chemists because you have to look at every single atom, and it becomes a bit overwhelming, especially when we get to large structures. So what you'll see in this class is generally chemists like to simplify these structures in what we call a skeletal structure. And so in a skeletal structure, this is what ethanol looks like. In a skeletal structure, each vertex, so each kind of point like this, or each terminus of a line like this, represents a carbon. In skeletal structures, most hydrogens are omitted. And then most non-carbon elements are drawn. Like here, you can see that I drew out the oxygen, and then I also drew out the hydrogen connected to the oxygen. But you'll notice I didn't draw any of the hydrogens connected to the carbon. And why are these skeletal structures so important for chemists to use? And why will we be looking at skeletal structures in the coming weeks? Well, I'll show you right now by drawing another drug that we'll all be familiar with, caffeine. Let's do this. Okay, I'm going to go slowly here, folks, because there is a lot to draw. Okay, folks, so that's how you draw caffeine. Lots of carbons, lots of nitrogens, lots of oxygens, lots of hydrogens. And you can see that on this image, I've drawn some double bonds as well, which we haven't really talked about in this class, but don't worry too much about that. This double bond just indicates that these two atoms are sharing even more electrons. But you might imagine that as a chemist, looking at a structure like this is a little bit complicated. It's a little bit busy. So using a skeletal structure like we did in this slide for caffeine is going to be incredibly helpful. Now what I'm going to do is I'm going to draw the skeletal structure, and you'll see how much more simple it is. And that's it, right? So to show you real quick, previous slide, oh my gosh, look at all the lines, look at all the letters. But on this slide, we are much more simplified because I'm not drawing out the individual carbons. I'm just doing kind of vertices or terminal points of lines. And most of the hydrogens, actually, in this case, all of the hydrogens are gone. Finally, folks, we'll have a quick video on looking at these structures overall and how we can kind of classify different structures.